Grounding aluminum cable trays is essential to prevent corrosion, electrical shock hazards, and damage to equipment. The most effective way to ground aluminum cable trays is to use exothermic welding, which creates a permanent low-resistance bond between the tray and the grounding conductor. The procedure involves several steps. Firstly, prepare the trays by cleaning the bonding surfaces on both the cable tray and the grounding conductor. Secondly, place the mold. Place the exothermic weld mold around the bonding surfaces. Thirdly, insert the igniter. Insert the igniter into the mold and activate it to ignite the exothermic reaction. Fourthly, focus on the bonding process. The molten metal will flow into the mold and create a strong bond between the tray and the conductor. To prevent corrosion at the ground connections, apply a thick layer of conductive grease or tape to the bonding surfaces before welding. This will create a protective barrier that inhibits the formation of oxides and prevents galvanic corrosion between the aluminum tray and the copper grounding conductor. If station grounds are within 3 feet, it is highly recommended to bond the cable trays to these grounds using exothermic welding. This provides a robust and reliable grounding path for the trays and the cables they carry. Additional tips to consider: 1. Use solid copper grounding conductors. 2. Bond the trays together at regular intervals along the run. 3. Ensure all bonding connections are tight and secure. 4. Inspect and maintain grounding connections periodically for any signs of corrosion or damage. Remember that proper grounding not only protects equipment and personnel, but also extends the lifespan of the cable tray system. The use of exothermic welding ensures a reliable connection that resists corrosion and provides a low-resistance path to ground. Regular inspections and maintenance are crucial to ensure the continued effectiveness of the grounding system. By following these guidelines, a safe and reliable installation is created. Consider the environment where the cable trays are installed. In harsh environments, such as those with high levels of humidity or corrosive substances, it's even more important to take extra precautions to prevent corrosion. This might involve using more robust materials for the grounding conductors and connections, as well as applying additional layers of protective coatings. The type of cables that the trays carry can also influence the grounding requirements. For example, if the trays carry sensitive electronic equipment, it might be necessary to provide additional shielding and grounding to protect the equipment from electromagnetic interference. Be sure to consult with a qualified electrical engineer to determine the specific grounding requirements for your application. The size and spacing of the cable trays can also impact the effectiveness of the grounding system. Larger trays and longer runs might require more frequent grounding connections to ensure that all parts of the tray are properly grounded. It's also important to consider the overall layout of the cable tray system when designing the grounding system. Ensure that all trays are interconnected and that there are no isolated sections that could become a source of electrical shock or interference. Proper documentation of the grounding system is also essential. This includes creating a detailed diagram of the grounding system, as well as keeping records of all inspections and maintenance activities. This documentation can be invaluable for troubleshooting problems and ensuring that the grounding system continues to function properly over time. In addition to the tips provided, it's also important to be aware of any applicable codes and standards that govern the installation and grounding of cable trays. These codes and standards can provide valuable guidance on best practices and can help to ensure that the installation is safe and compliant. Furthermore, consider the impact of future modifications or expansions to the cable tray system on the grounding system. It's important to design the grounding system in such a way that it can be easily adapted to accommodate changes in the cable tray layout or the type of cables that are being carried. This might involve using modular grounding components that can be easily added or removed as needed. Finally, it's important to remember that grounding is not a one-time task. It's an ongoing process that requires regular monitoring and maintenance to ensure that the grounding system continues to function properly over time. This includes periodically inspecting the grounding connections for signs of corrosion or damage, as well as testing the resistance of the grounding system to ensure that it is within acceptable limits. By following these tips and best practices, a safe and reliable grounding system for aluminum cable trays can be created. This will help to protect equipment and personnel from electrical hazards, as well as extend the lifespan of the cable tray system. Consider the conductivity of the soil in the area where the cable trays are installed. In areas with highly conductive soil, the grounding system may be more effective than in areas with less conductive soil. If the soil conductivity is lower, it may be necessary to use additional grounding electrodes or other techniques to improve the effectiveness of the grounding system. Also, consider the presence of any underground utilities in the area where the cable trays are installed. Before installing any grounding electrodes, it's important to locate all underground utilities to avoid damaging them or creating a safety hazard. The location of the grounding electrode should be carefully chosen to minimize the risk of interference with underground utilities. The type of grounding electrodes used can also affect the performance of the grounding system. Common types of grounding electrodes include ground rods, ground plates, and concrete encased electrodes. Each type of electrode has its own advantages and disadvantages, and the best choice for a particular application will depend on the specific site conditions and grounding requirements. Ground rods are a common and relatively inexpensive type of grounding electrode. They are typically made of copper or copper-clad steel and are driven into the ground to provide a low-resistance path to ground. Ground plates are another type of grounding electrode that can be used in areas where it is difficult to drive ground rods, such as rocky or paved areas. Ground plates are typically made of copper or steel and are buried horizontally in the ground. Concrete encased electrodes are grounding electrodes that are encased in concrete. They are often used in new construction projects, as they can be easily integrated into the building's foundation. Concrete encased electrodes can provide a very effective grounding system, but they can be more expensive to install than other types of grounding electrodes. In addition to the type of grounding electrodes used, the size and spacing of the electrodes can also affect the performance of the grounding system. Larger electrodes and closer spacing can generally provide a lower resistance path to ground. The optimal size and spacing of the electrodes will depend on the specific site conditions and grounding requirements. The National Electrical Code, or NEC, provides detailed requirements for the grounding of electrical systems. It is important to consult the NEC to ensure that the grounding system for aluminum cable trays complies with all applicable requirements. The NEC specifies the minimum size of grounding conductors, the types of grounding electrodes that are permitted, and the methods for connecting grounding conductors to grounding electrodes. The NEC also includes requirements for the bonding of metal parts, such as cable trays, to ensure that they are all at the same potential. Bonding is the process of connecting metal parts together to create a low resistance path for fault current. This helps to prevent electrical shock hazards and equipment damage in the event of a ground fault. In addition to the NEC, there may be other applicable codes and standards that govern the installation and grounding of cable trays. It is important to be aware of all applicable requirements and to ensure that the grounding system complies with them. Regular testing of the grounding system is important to ensure that it is functioning properly. Ground resistance testing can be used to measure the resistance of the grounding system to ground. This test can help to identify problems with the grounding system, such as corroded connections or broken grounding conductors. Ground impedance testing can be used to measure the impedance of the grounding system at different frequencies. This test can help to identify problems with the grounding system that may not be apparent from ground resistance testing. Regular inspection of the grounding system is also important to identify any signs of corrosion or damage. The grounding connections should be inspected to ensure that they are tight and free of corrosion. The grounding conductors should be inspected to ensure that they are not damaged or broken. Any problems that are identified during the inspection should be corrected promptly. Proper maintenance of the grounding system is essential to ensure that it continues to function properly over time. This includes cleaning the grounding connections, tightening any loose connections, and replacing any damaged or corroded components. The grounding system should be inspected and tested regularly to ensure that it is functioning properly. Remember, a well-designed and properly maintained grounding system is essential for the safety and reliability of electrical systems. By following the tips and best practices outlined here, a safe and effective grounding system for aluminum cable trays can be created. Always consult with a qualified electrical engineer or electrician to ensure that the grounding system complies with all applicable codes and standards. They can provide valuable guidance on best practices and can help to ensure that the installation is safe and compliant.